in previous session you derived these two formulas. Yes. Okay. Now let us see the numericals based on these formulae. Before that, consider some points. See here, W max is equal to, that is maximum work, is equal to minus 2.303 N. N, that is number of moles. That is W upon M. W, that is a mass of gas, and M, that is a molar mass of gas. Suppose it is in a gram, then this is also in a gram, that is it is in a gram per mole. Okay. Or suppose it is given in a kg, then it is also used in a kg per mole. Okay. Therefore, unit for N is mole. Next, R, value of R given in the exam, it is 8.314 joule per Kelvin per mole. Okay. And the temperature, take always in Kelvin. Any numerical from chemistry, always in Kelvin. Next, now volume. Here it is a ratio. Therefore, volume unit any, that is volume in any unit, but V2 and V1 must be in a same unit. Okay. Therefore, now find out mole per Kelvin, Kelvin. That is remain joule. Therefore, the unit of W is joule. Or if it is in a kilojoule, then it is in a kilojoule. Or remember only this, the unit of work and temperature, are either in a joule or both are in a kilojoule. Okay. Anyone. Same for this formula. Here again same. P1, P2, here ratio is there. Therefore, unit of pressure any, but both should be in a same unit. Okay. This is the one thing. Next. Now, remember one more thing. Here, if gas is compressed, then work is positive. The sign of W is positive. And if it is expansion takes place, then W is negative. Remember, this is same for PV type of work. Okay. Now let us see first numerical. Calculate the maximum work, that is to find maximum work, W max. When 24 gram of oxygen, that is given here, WO2, weight of oxygen 24 gram, expanded isothermally and reversibly. Expanded indicates W max obtained, here negative. Next one, from the pressure of P1 is equal to 1.6 bar to 1 bar, 2, that is P2 1 bar, and temperature 298 Kelvin is given in Kelvin. Okay. Now formula, W max is equal to minus 2.303 nRT log to the base pressure given, therefore P1 upon P2. Now substitute the values here, minus 2.303 N. Now N, W given, find out first molar mass. Molar mass of O2, 16 plus 16, that is 32 gram per mole. It's a molar mass. And now find out number of moles. Always find out number of moles separately here. Mass are allotted to that number of moles. Therefore, N is equal to W upon M. Here 24 gram divided by 34 gram per mole. Therefore, it's equal to here 3/4, that is 0.75 mole. Yes, am I right? Next, now number of mole 0.75 into R given in the exam 8.314 into T 298, then log 1.6 divided by 1. T1 is 1.6. Now first find out the log of this one. At the time of exam, you are supplied with the log table. Do the calculation by using log table only. Therefore, minus 2.303 into 0.75 into log of 1.6 is 2041. Now here multiplication, do the calculation by using log table. Log of this is 0.3623. Then log of this is a bar 1.8751. Then this one 0.9198. 298, that is 2.4742. And for this it is a bar 1.3098. Now addition of all these logs, here multiplication, here 2, 1, 4, then 9. Now to cancel, to remain. Now the antilog of this is 873.4. Okay, that is here minus this one minus 873.4. Unit is Joule W max. Therefore, W max is this one. Now, once again check that. Find W max here. W max sign unit here. Okay. Now, numerical is over. Let us see next numerical. Now, next numerical here. 3 moles of an ideal gas that is given N is equal to 3 mole. Next, are compressed isothermally and reversibly. Compressed, W is positive. 2 a volume of 2 dm cube, that is V2 is equal to 2 dm cube. The work done is, that is W max. W max, it is positive as it is compressed 2.983 kilojoule given. Okay. At 22 degrees Celsius, temperature is equal to, it is given in 20 degrees Celsius. Therefore, 273, which is equal to, T is equal to 295 Kelvin. Yes. Calculate the initial volume. That is, find initial volume, that is V1 is equal to question mark. Okay. Now, first thing, formula W max is equal to minus 2.303 nRT log to the base 10. Here volumes given, therefore V2 upon V1. Always remember, before substitution, first convert the values in required unit. Now this R and W must be in the same unit. It is in a kilojoule. Convert it into joule. First, that is plus 2983 joule. That is equal to 2983 joule positive. Okay, which is equal to, now here not required, minus 2.303 N 3 mole, R given in the exam, T 295 log to the base 10, V2 given 2 and V1 we want to find out. Okay, next. Now this keep as it is on this side. Now shift this side, that is Now consider work, that is log to the base 10 2 by V1 is equal to, now this here, therefore 2983 divided by 2.303 into 3, 8.314 into 295. Okay, use log calculation. Now first we find out the multiplication of this, that is the addition of log of this one. It is a log of 0.3633 is a 0.4771. Next 0.989198. Then it is a 2.4698. Okay. Now yes, it is 2, it is 9, 2, 2, again 2, then 4. Okay, that is this one, the sum of log of this. Now this one, log of this, that is characteristic here, 3 point, the log of this is 4746 minus the sum of this, that is this one, 4.2290. Now subtract this minus this, 6, then 5, then 4, then 4, 2, next one is a bar 1. Yes. Now the anti-log of this bar 1, that is 0.1760. Okay. Now here it is minus 0.176. Okay. That is a log 2 by V1. Now see here, multiplied by anti-log on both sides. But after that, the anti-log of this negative value not possible. Therefore, first convert this to positive one. See here, this is means log 2 minus log V1. Now, opposite minus in bracket log V1 minus log 2. Therefore, in shortcut, that is, see here, we require plus here. Therefore, log 2 V1 upon 2. It is same. Here it is plus. Therefore, 176. Remember this step. Okay. Now, multiplied by antilog on both sides. That is, V1 upon 2 is equal to antilog of 0.176. Antilog of 0.176 is 1.5. Okay, that is V1 upon 2 is equal to 1.5. Therefore, V1 is equal to 2 into 1.5, which is equal to 3. Now, the unit of V2 is dm cube. Therefore, it is also dm cube. 3.0 dm cube. This is V1. Okay. Next. Now see here, one more thing. Here gas is compressed. Now V2 is 2 dm cube. That is final volume. That is, initial volume must be greater than this. Tell you that it is greater than this one. Okay. Now volume with the unit, answer is here. Okay. It's about the numerical. Next, C1. Now next, last problem. Here, 3 moles of an hydrogen gas are compressed isothermally and reversibly. Here given 3 moles. That is, N is equal to 3 mole. Next, compressed W is positive. From liter, that is, it is a volume V1 60 liter, to, that is V2, is a 20 liter. Okay. Next, and work is W max because process is isothermal and reversible, therefore W max 8.50 kilojoule of work is done on it, that is compression. Assuming ideal behavior, calculate the temperature of the gas, that is find temperature. Okay. Now formula W max is equal to minus 2.303 nRT log to the base 10 volumes given, therefore V2 upon V1. Now substitute the value. Before substitution, always remember one step, convert into required unit. Now here it is in joule, therefore convert this into joule as a 8500 joule, and this is positive as gas is compressed. Yes, am I right? Next, now here 8500 to minus 2.303 N 3 moles, R is 8.314, then temperature is, we want to find out, into log to the base 10, as V2 is 20 and V1 is 60. Okay. First, convert that this value, first solve this part, that is this 8.314 into T into log 1 by 3. Yes. Now see here, this means that log 1 minus log 3, and log 1 is always 0. That is 0 minus log 3. Now this minus log 3 and this minus, that is positive. That is 2.303 into 3, 8.314 into T. I will give you one trick after this numerical. Okay. Into log to the base 10, 3. That is, if you invert like this one here, then this minus become positive. Just if you solve by mathematics, that is correct one. Okay. Now, first substitute the value of log 3 is 8.314 into T into log 3 is 0.4771. Okay. Now, here it is a 8500. Now, I want to find out this T. Keep that T here and rearrange this one. This 8500 divided by this 2.303 into 3 into 8.314 into 0.4771. Now solve by using log table. See, first solve this one. This 0.3623. 3, that is 4771. 0.9198. Okay. Then log of this, it is a bar 1.6786. Now the sum of all this, see here, 8, 7, then 3, 4, and here it is a 1. Okay. Now, log of this minus now this one, log of this, that is 3 point, the log of this is 9294 and minus 14378. That is the log of this minus log of this. Now here subtraction, here 6, then 1, then 9, then yes 4, and here 2. Now the antilog of this is 3101. Now point here, that is this one, that is equal to 310.1. Now it is a temperature, it is in a Kelvin. Therefore this is the answer. Now check that. What is asked? Find temperature. Temperature unit. Okay. Now let us see some tricks and tips to solve this numerical in competitive exam. Okay. Some tips for competitive exam. See here, we are using this and these two formulae. But suppose in the numerical gas is compressed, that is compression is there, then you have to use these formulas. That is volume given, then for expansion this formula, for compression this formula. Okay. Next, pressure given, then for expansion this formula, for compression this. Okay. Similarly, PV type of work, that for expansion this one and for compression this one. Next, one more tip. Now, you know the value of R. Therefore, this into this gives this one. Suppose 1 mole, that is for 1 mole, this value is 19T. And the sign depends on expansion or compression. Now, let us consider homework. You have to solve the numerical from the homework. And in next session, we will consider the work done in chemical reaction.